Good morning. My name is Dara Dwayne, and I am your host for Science Pill. I am here today with Mary Hiller, who will be walking us through a cool chemistry experiment. And I think a lot of you all are going to really dig this. So I don't want to like hold us up and eat any more of our time. So to no further ado, I introduce to you Mary Hiller.
Hi, thank you, Dave. So good morning, everybody. Hope you're having a good Tuesday, and welcome to Science Pill Live. So during this presentation and the demonstrations I'm going to do for you, what I want you to do is go into the question and answer section and type in your responses, because I'll ask you questions about what you think is going to be happening, and I want your feedback. So I want to encourage you to be using the Q&A section to tell me what you think is going to happen when we do these experiments. So let's go ahead and start with our presentation. So Sylvia, if you can bring up the screen for me there. Thank you. Whoop.
1 second, Mary. For some reason, the presentation has disappeared from my screen.
Okay,
so give me a couple of seconds.
You're fine. We have time.
And while we wait, Mary, what might be some things that they might want to gather if they wanted to participate? It looks like we are almost there, but you can give us a quick rundown, a list of items you might be using.
Well, what I would say is that refer back to the video when it's posted up, rather than getting stuff now, because they might be running around trying to find things and miss part of the presentation. So information, they're a little more obvious as to the materials that you can actually get from and do these experiments yourself too. But that being said, I want to make sure that everybody watching, if you choose to do these experiments at home, you need adult and you need adult assistance with this, because this is not something I want you to be doing on your own. So let's go ahead and start with our presentation about chemistry and just how cool it can be. And chemistry you can do at home. So the experiments we're going to be doing today are all based on using liquid that you can extract from red cabbage, the dye you can get from the cabbage, and how that dye can actually tell us a little bit more about the materials that we use that are in our kitchen and in our household. So let's go to our first slide. Let's go to the next slide and learn a little bit about what chemistry is. So let's go to the next slide. So what is chemistry, and why are we focusing on chemistry today? So chemistry is the study of what everything is made of and how things behave. So how things interact with each other as we mix materials together. So some examples of chemistry are cooking, making your own paint, and how your stomach digests food. So we actually use chemistry every day of our lives, when we eat, when we make our food, and taking care of our bodies as well. So today's focus is going to be specifically on chemical reactions that we can visibly see and that you can create at home, again, with adult supervision. So let's learn a little bit more about what we're doing today. So let's go ahead and go to the next slide. There we go. So our experiment today is we are going to be using red or purple cabbage, depending upon how you refer to it, to explore the worlds of acids and bases. So the image that I have there is of red cabbage that I have at home here. I've gone ahead and created what we're going to be using for exploring our acids and bases, and you'll learn a little bit more about how to do that yourself a little bit later on. So using purple cabbage is going to be a benefit to us today. So let's go ahead and go to the next slide. So the first thing we need to talk about is, well, what are acids and what are bases? So acids you might be more familiar with than bases, because there are a lot of acids in different types of food. Acids tend to have a sour or tangy taste. So things like orange juice and lemon juice are acids. If they're strong enough acids, they can actually dissolve metal. They have a pH number of 0 to about 6.9. We're going to talk a little bit about what pH is in just a moment. Acids can be poisonous. The more acidic acids, the more dangerous they are, they can be very poisonous and very bad for the human body and for the environment. So we do have to be aware of how acidic something is. And again, one example of acid would be orange juice that you might drink for breakfast. Bases, on the other hand, have a very bitter taste to them, whereas acids are very sour and tangy. They feel a little soapy when you rub them between your fingers, and they have a higher pH number of anywhere from 7.1 all the way up to 14. Again, they can be poisonous too. The more and more basic you get, the higher you get in that number, the more dangerous that base can become. So bases can be poisonous too. And one example of a base that you might have in your kitchen would be baking soda. So let's go to the next slide. Here we go. So I mentioned pH in the previous slide. We're going to talk a little bit about what pH is and why it's important. So pH is a measure of how acidic or how basic a substance is. Here you see an example of the color code we are going to be using today to measure our acids and our bases. You'll see on the left-hand side, our acids go from 0 to almost 7. Our bases go from 14 down to almost 7 as well. So bases are on the right-hand side, acids are on the left. For acids, the lower the number, the more acidic the acid is. So when you get down to a 0, you're talking about some very, very potent and dangerous acids. So we are not going to be using anything near a 0 pH acid because that would be unsafe. And also it's not something that's common and found in the household. Whereas with bases, if you look all the way over to 14, we have this very bright yellow color. That is some of the most basic material, and that again can be hazardous. So the materials we are going to be using today are going to be somewhere around that 7. That 7 that you see in the middle, you notice it's that purple color because we're using red or purple cabbage today. That is what's going to be called our neutral, meaning that it's not acidic and it's not basic. It's kind of in the middle. So we're going to see how that material that's considered neutral is affected as we add an acid or a base to it. So this is an example of what you can actually use a linear key of colors to identify what an acid, oh, go back 2 slides. What a linear list of colors can actually teach you more about the colors that you're seeing when we do our experiments today. Okay, so go one more slide forward. So the reason that we're using red/purple cabbage is that it has a natural pigment in it that is very sensitive to acids and bases. So it changes color. So that natural purple color we get from the purple or red cabbage when we cook it is going to change color depending upon if we add it to an acid or a base. Let's go forward one more. So this is probably the most important part of the presentation. If you want to do this activity at home, this is how you make the red cabbage indicator. So you are going to need adult supervision to do this because it does require using knives, it does require cooking on the stove or using very hot water from a coffee machine. So first thing you're going to do is you're going to get an adult to help you with these steps. You're going to dice up about 1/4 of a cup of red cabbage into small pieces. You're going to put those pieces of diced cabbage into a saucepan and add about 1.5 to 2 cups of water. This can be tap water. It doesn't have to be hot. It doesn't have to be room temperature. You can get it straight out of the tap. You're going to cook the water and the cabbage on the stove at a low heat for about 30 minutes. And then you're going to let it cool completely. This is going to allow a lot of those dyes, a lot of those pigments from the cabbage to seep out into the water. So you're going to have this beautiful deep purple dyed water that is dyed from the cabbage. Now you need to make sure that you let it cool completely in that pan before you do anything else. We don't want anyone getting burnt thinking that they're going to hurry up and pour it into another container. So please let it cool completely before moving on to step 4. Now with step 4, you can either pour the juice and leave the cabbage in, pour the juice into a glass jar, or you can use a plastic one as well. Or you can put a sieve over the opening of the jar and pour all of your contents in your saucepan into the sieve, and it'll drain the juice into the jar, and then you can simply throw away the pieces of cabbage that are left. What you want to do is, again, make sure that that is now room temperature. It has cooled completely. You can go ahead and cover it and refrigerate it, but you want to be sure that you use it within 2 to 3 days of making it, because since cabbage can get very stinky, the water can get very stinky too. So you want to make sure you use this red cabbage indicator as soon as possible within, say, 2 or 3 days of making it. Now, if you are not allowed to use the stove with adult supervision, perhaps an adult can help you by making some hot water in a coffee machine, and you can pour that over the red cabbage in a container and let it sit for 30 minutes. Let it come to room temperature, let it cool completely, and then you can strain it the same way. And that's actually how I made my red cabbage indicator. I used a hot coffee machine, and I made hot water with it, and I poured it into a glass jar with my cabbage and just let it sit for a half an hour. So let's go to the next slide. So now that you have an idea of how to make it, we're not going to spend the time to have you make it today. You can do it on your own, because you can refer back to this video when it is uploaded, when we're done doing the live stream. But now we are going to go ahead and we are going to test our red cabbage indicator. So the materials we are going to be using today are ones that you should be able to find in your home. If you don't have everything, that's perfectly fine. But one thing I do not want you to do is try to test random things in your house, like dishwasher soap or laundry soap or any sort of chemicals that might be used for cleaning. We're not going to do anything like that. We want to make sure that we are doing safe science and safe chemistry today. So we are going to be testing lemon juice, vinegar, clear soda pop, baking soda, and toothpaste. So 5 different things we are going to be testing today in our experiment. So are you ready to experiment? What I want you to do is go to that Q&A section at the very bottom of the screen, click on where it says Q&A, and type into the Q&A section. Let me know if you're ready to experiment. And I'm going to go ahead and start preparing some of my materials. So I'm going to show you what I have with me today. You just saw it in the previous slide. I have my vinegar right here. I have my lemon juice. I have my clear soda. I have my toothpaste. And I have my baking soda. So we are going to start with our lemon juice. Now what I'm going to do is, when I'm doing these experiments, you can do the same thing at home on your own time. I have these nice little glass containers that I can pour a small amount of our test material in and then add the red cabbage juice into it. If you don't have something like that, you can easily use a plastic water bottle and pour a little bit into the bottom and then pour your indicator in afterwards. You'll still see the same reaction. So if you don't have something glass to use, that's perfectly fine. You can use a plastic bottle or a plastic container to try these experiments in. But at no time should you be mixing, say, your lemon juice and your vinegar, or your vinegar and your baking soda, or your soda pop and your toothpaste. We're not going to be mixing our acids and our bases together and then adding in the indicator, because we want to make sure we keep ourselves safe. So we're going to be doing individual testing today. So we are going to start, as I said, with our lemon juice. All right. So I'm going to take one of my containers here, and I'm going to pour in enough lemon juice for you to be able to see it on the screen there. All right, so there's my lemon juice. I'm going to cap up my container, and I'm going to show you what my red cabbage indicator looks like using another container. So I have it in a nice little ball jar, a little glass jar. I use one of the normal lids you would use for canning to keep it sealed. Now I did make this yesterday, so it is getting a little stinky. I'm going to go ahead and pour that into our container here, enough to where you can see the original color of it. It's a little bit hard to see with the light coming in from that side, but it is actually a very deep purple color. So we are going to take some of this red cabbage indicator and we are going to add it to our lemon juice. Now, what I want you to do is, for those of you who can type in, I want you to make a prediction. Do you think the lemon juice is going to change color, or do you think it's going to stay the same yellow color that it is now? What do you think is going to happen? Go ahead and type it in. All right, so let's go ahead and experiment. So here we have, I have a little teaspoonful of our red cabbage indicator. I'm going to pour it into our lemon juice. Okay, so we think it's going to change color. Okay, since it's a juice just like orange juice, good, it's going to change. So let's see what happens. Let's pour it in. And let's add a little bit more. All right, so what color did it change to? So what color did it change to? Good. So it changed to a very sort of light pink color. Now, if you think back to that color key that I showed you, remember our acids were on the left-hand side and they tended to be more in the reds and pinks, whereas our bases were on the right-hand side. They tended to be more in the greens, the blues, and the yellows. So is this lemon juice, good, is this lemon juice an acid or is it a base? Good, it is an acid, absolutely. Now, does that make sense for those of you who've had lemon juice before or lemonade before? Does it have that kind of tangy flavor to it? That would make sense that it is an acid. So let's go from our lemon juice, let's go to our vinegar and see what happens. So I still have some of my purple cabbage water here. I'm gonna go ahead and take another container and I'm gonna put my vinegar in it. So just a little bit of vinegar so you can see it here. There we are. So we see our vinegar is very clear. So let's ask that question again. Do you think the vinegar is going to change or is it going to stay the same when we add our indicator to it? Think about the way vinegar tastes. Do you think it's going to do the same thing as the lemon juice? Do you think it's going to do something different? Okay, so someone said it's going to change. Anyone else want to volunteer some ideas? What do you think is going to happen? Okay, so we have quite a few people saying it's going to change. So I'm going to take another teaspoonful of my indicator. I'm going to add it into our vinegar and you're right, it does change. So let's add another spoonful in there. Just a little bit more. There we go. So let's go back to our lemon juice and let's compare the two. Is there a color difference between the two? Is one more reddish than the other? So this is the vinegar and this is the lemon juice. Is one more red than the other? The vinegar is redder, absolutely. So would that mean that the vinegar is a stronger acid or a weaker acid than our lemon juice? You're right, vinegar is going to be stronger because it's more of a deeper red. That's about as strong as we are going to go with our acids, because if we go way down to where 0 is, we're talking some very, very dangerous types of acids that I don't want you messing with. I personally don't want to be messing with either. So again, we want to make sure that we are being safe. Excellent. So let's do our soda pop. Let's do our clear. And the reason I chose clear soda pop is because it's easier to see the change in this rather than using something that has a caramel color to it or that has food coloring in it already, like an orange pop or a grape pop. This will allow us to see the change a lot better. So let's go ahead and pour some of our clear soda into our container. You can see it there. And let's go ahead and add our indicator to it. So I'm going to take a couple teaspoons add our indicator in. Lift it back up so you can see here. So here we go. Again, do you think it's going to change? Do you think it's going to stay the same? For clear soda pop, it tastes tangy, so someone thinks it's an acid. What do we think is going to happen? Good. Okay, so let's go ahead and add it in. And what change did we see? We saw that it indeed did turn pink. So we are seeing again an acid. Now, this requires a little bit of going into a little more detail. How many times has the dentist told you brush your teeth after every meal, and especially after drinking sodas? That's because the acid in the soda can actually damage the covering of your teeth, the enamel, so it can wear it away because it is an acid. It is going to eat away at the covering of your teeth, that protective enamel. So this is why dentists always say, yeah, exactly. This is why dentists always say to brush your teeth after every meal, because it helps to nullify the acids in the foods that we eat. So let's continue on. Let's go to our baking soda. Now, how many of you have done an experiment where you've combined baking soda with vinegar? Who's done that before? Okay, yep, to make a rocket, absolutely. How about for like one of those homemade volcanoes? Yep, absolutely, perfect. So, since we know that vinegar is an acid, what do we think baking soda might be? What might the baking soda be? Is it going to be an acid too? Or is it going to be something else? It might be a base. Okay, so let's do an experiment. Easiest way to figure out if it's an acid or a base is to add some to a container, and we're going to add in our indicator. So you can see, it's maybe a little bit hard to see there, but you can see a little bit of the material there, a little bit of my baking soda in our container. I'm going to go ahead and I'm going to pour the remainder of my indicator that I have in this cup into there. And let's see, what color do you think it's going to change? Or do you think it's going to change? Is it going to be purple like the indicator, or do you think it might change? Think back to when we had those acids and bases. Okay, not red. That's a good way of putting it, because we know acids are going to be on the red and pink side. With the bases, you start with your purple, where we are at our neutral, and you go more into the blues, then into the greens, then into the yellows. Now think, baking soda is something that we can eat because it is something that is used in baking. It's used in making cookies and different types of food. So it is not poisonous in that way, but too much of it, or too much of anything, can be damaging to our bodies. So this is a safer material to use. So let's go ahead and add our indicator to our baking soda and see what happens. So I'm just going to go ahead and pour it in. And I'm going to mix it around. I have a little stick right over here to mix. And what color do you see? Blue, yes, exactly. So does this mean that baking soda is an acid or a base? A base, absolutely. So we've seen some different acids turn red as we add this indicator in. We've seen a base now turn this beautiful blue when we added our indicator in. So this red cabbage indicator is actually very useful in exploring acids and bases that are found in your own kitchen. Now, the last thing that we are going to experiment with is toothpaste. So we are going to explore whether toothpaste is an acid or a base. So you might already have an idea, because I alluded to this when I was talking about dentists saying you should brush your teeth after every meal. We're going to go ahead and add some toothpaste into our container, not too much. And what I'm going to do is I'm going to kind of smush it around here a little bit, because it's going to take a little bit of time to make it into a paste where the red cabbage indicator is going to mix with it fairly well. So I have my paste sort of smooshed over to the side and turn it this way. There, you can see it a little bit better. So I'm going to get my red cabbage indicator. I'm going to pour myself out a little bit more. There we go. And we are going to, I'm going to try to put that down somewhere safe. So I'm going to pour this red cabbage indicator into the toothpaste. What do you think is going to happen? Is it going to turn color? Is it going to stay the same? Do you think it might turn pink? Do you think it might turn blue or some other color? What do you think? Okay, not acid, maybe turning blue. Okay, so let's go ahead and add it in. And this is going to take me a little bit of time to mix it together because, again, we're using a paste and then also our indicator. Let's mix this up. Okay, and so there we go. What color did it turn? It turned blue. So what does that make toothpaste? Toothpaste then has acid or it has a base in it. Which one does it have? It's a base, absolutely. And again, as I said before, when your dentists tell you brush your teeth after every meal, it's simply because all the acids that our saliva creates in our mouth and the acids that we use to digest our foods, we don't want that acid, and even acids in our foods too that we eat, like vinegar and lemon juice. We want to make sure that we clean our mouths from that acid so that it doesn't create a situation that is damaging to our teeth. So that's why it's so important to brush your teeth every single day. So those are examples of different types of materials you can test on your own using red cabbage indicator. So I can't hold them all up at the same time because they are in larger containers, but I did happen to find this handy dandy icicle pop maker. So I put in, let me move my chat box here. There we go. I did put in our soda pop, our vinegar, our lemon juice, our baking soda, and I combined my toothpaste with a little bit of water. So I'm going to go ahead and add in the indicator yet again. If I can find my, oh, there it is. Find my teaspoon. I'm going to add my indicator in again to each one. So this way we can see them one next to the other. So there's 2 teaspoons for our soda. There's about 2 teaspoons for our vinegar. There's 2 teaspoons for our lemon juice. We might need more than 2 teaspoons for our baking soda. And I might need to mix that just ever so slightly. And then also for our toothpaste here. 2 and 3. So I'm going to mix these up. There's 1. The acids I don't need to mix up because they are very liquidy to begin with. I'll use the other end so we don't cross-contaminate. And you can see the blue on that too. So again, we have our soda. We have our vinegar. We have our lemon juice. We have our baking soda. And we have our toothpaste. So in your own home, you have examples of acids and bases that are very easy to get from your kitchen, from your bathroom, and you can do this experiment at home as well. So that ends the experiment portion of our lesson today. But again, I want to say again that you need to make sure you are doing this with adult supervision. I want to make sure that nobody is trying to test things randomly in their house, because there can be very, very bad reactions if you start to mix together and not know what's going to happen. One thing that I know never, ever, ever to mix together is bleach and vinegar, because it makes an actual poisonous gas that can send you to the hospital. So that's why you don't want to be mixing different things together randomly. Only test the ones that we've done here today in this lesson, okay?
Thank you so much for that, Mary. This was low key awesome. I feel smarter
Yay!
just by participating. So we do have a couple of questions that are dropping into our Q&A panel really right at this moment. So we'll jump into those. And then again, if you have any questions, viewers, we do encourage you to include your questions in our Q&A panel. And if you're watching via Facebook Live, you can also DM us or message us your questions. And at our next Science Pill Live, we would definitely answer those questions for you. So we're going to start off with the first question, which is a great mom question. So mom asked, if we accidentally spill the cabbage juice, how do you get the stain clean? Is it easy to clean, or basically, how do we clean? Yeah, so how do we clean the cabbage so it doesn't stain? I'm sorry, I misread that question.
So with the red cabbage juice, when I made it, I did get some on the countertop. Basically, just wiping it down with a wet paper towel as soon as it is the best way to do it. If it actually does stain, what I would tend to do is actually baking soda is a great cleaner as well. You just put a little bit of baking soda on the surface of whatever cabinet or countertop. Just give it a little bit of a scrub, not too much, and then wipe that clean, and that'll take care of it too. But that's another good point. When we are doing these experiments, you want to make sure that you set yourself aside a space to do the experiments in. You don't want to sit down in the middle of the carpet and start doing this stuff. You want to separate an area out. And actually, you could use something like a cookie tray to put your things on so that if anything does spill, it'll spill into the cookie tray so it's clean up. And also, since we have all of our acids and bases here, to get rid of these, what you can do is do them one at a time. Turn on the faucet at home in your kitchen and pour it down the sink, but use a lot of water down the sink. Then you can go with the next one and the next one. You don't want to be adding them all in at the same time. So you want to make sure you do them one at a time and then use a lot of water to flush them down, okay? But most of this stuff, you know, is not going to be harmful to the environment, small amount anyway. And you are adding a lot of water to not necessarily nullify, but to sort of limit the amount of acid that's passing through the system at any one time too. Okay? Oh, mom says thank you. You are welcome.
So again, we encourage you to put in more questions. We do have a couple of more minutes, so if there are any more questions you have, please drop them in our Q&A. I do want to ask you, Mary, a question. So referencing back to stains, right? So does that mean that a lot of our soap detergents that we use are also more base inclined
Yes.
because of the quality that
they are.
Okay, all right.
A lot of the detergents that we use, the hand sanitizer, the dish detergent, the laundry detergent, that's going to be very basic. So I don't want to encourage people to experiments with those because, again, the severity of the base that's used in that's a reason why that's not considered, you know, food grade or anything like that. So we don't want anybody messing with those kind of chemicals because, again, trying to keep the science as safe as possible since it's not in a controlled area like a laboratory teaching about it. So we want to make sure we are using things to where we are limiting the danger as much as possible.
And I think that's really important for our viewing audience to, you know, take note that we do not want to randomly mix chemicals. We want to make sure that we're taking the proper precautions to keep ourselves safe. Feel like I have a sneeze. Sorry about that. Oh,
okay.
Excuse me. There it is. So moving right along. Again, so when it comes to other items in your kitchen that may be safe to experiment, what might be some items that would be safe for us to, if we wanted to continue this exploration of kitchen chemistry? What might be some other items we might be okay to safely check to see if their bases are acids?
I would say any kind of juice, although to realize that some juices are not going to be clear. So it might have a color combination in there, like with apple juice, that typical color of apple juice anyway. So you might see a similar sort of pinkish color to it, but it might not be as say lemon juice or vinegar. Let's see, what else? Citric acid is something that you can use too. That's more of an acid that is in a lot of foods. But I don't think a lot of people are going to have citric acid just by itself at home. You can try some other, what other bases could we use? Oh, you could actually try broccoli. I just learned about this yesterday. If you puree it, broccoli is actually, it actually does have basic principles to it. So it's not acidic, it's basic. Because you remember broccoli, a lot of people has that very bitter flavor to it. That's
Hmm.
because it does have some base, or it does
So,
have base.
so are
You,
there acidic vegetables?
oh yes, yeah, definitely. Any kind of citrus fruits, berries are going to be acidic too. So you could even puree up types of fruits if you want to, and then test them with the red cabbage indicator and see how they turn out. Or the same way that we made the indicator by dicing things up and then letting them soak in hot water, you might be able to do that with some colorful berries or with some other fruit that might be able to leach their dyes out. And you can test it back and forth and see that way. Because mixing together liquids that you extract or that you create by cooking the fruits,
Hmm.
that should not give you any sort of bad chemistry to where you're going to cause any sort of dire situation that you're going to be in. So I would say with food is going to be a good thing to do. But again, keep in mind the situation that we're all in now too. Don't go and start using up things just to do kitchen chemistry. Need to keep, because we are all still self-quarantining, we are all still social distancing, we're supposed to wear masks to go to the grocery store. So be mindful of what you are going to use to experiment with this so that you're not using up something that really should be used for something else.
And that is a great point, and something that I do hope all of our viewers take into account to be mindful. So with that, that sort of wraps up our first ever live science pill. So Mary, congrats, awesome job.
Yay!
So if you love live science, if you love live chemistry, this is for you. We do pre-recorded science pills, as well as from time to time we'll do these live science pill sessions. And we'll be interchanging them on our social media platforms. So by all means, we encourage you to tune in. All of that information you can always find in our Instagram stories as well as our Facebook stories. And if you're at a loss at trying to navigate either system, you can find all that information on our website as well. I do want to encourage you to join us in our Community Day festivities we're going to be doing this Saturday. So I know all of us are mostly, for the most part, at home. And even though we have the COVID-19 situation keeping it very are making it very difficult for us to gather. We are going to assemble virtually, and we're going to press forward with our community event. So we encourage you to come check us out. There are going to be lots of cool things happening. A whole list of activities are listed on our website. So if you're interested, our community day is focused on planet Earth and celebrating our beautiful planet Earth. All that information can be found on our website at newarkmuseumart.org or on Facebook and or on our social media platform, Instagram. So again, thank you so much. We appreciate you, Mary. We look forward to seeing you back here later on this week for our Community Day event, which is Saturday. And we hope to see you Thursday for our Lunch and Learn session. It's going to be a lot of fun. Till then, have a great one and enjoy the rest of your day.
All right, bye-bye. Thanks, everybody.
Bye.